In this part of episode 1, we are going to be talking about the operation called exponents. And exponents are used to represent when a number has been multiplied with copies of itself. So just like multiplication represented repeated addition, exponents represent repeated multiplication. So someone could say, for example, raise 3 to the power 2. If someone says something like this, raise 3 to the power 2, they're asking you to take 2 copies of 3 and multiply those two together. Raise 3 to the power 2, take 2 copies of 3 and multiply them together. So the result of that would be 3 times 3, 9. This is one of the major ways to calculate exponents, to just remember that these represent repeated multiplication. So for example, if I said raise 2 to the power 5, this would be asking me to take 1, 2, 3, 4, 5 copies of 2 together and multiply them together. So in total, if I take 2 and multiply 2 times 2 times 2 times 2 times 2, the result of that would be 32 units. You can also use the calculator to calculate exponents directly. If I wanted, for example, in the calculator to raise 2 to the power 5, then in the Windows 10 or Windows 11 calculator, the symbol that I would use is this one right over here on the far left, this X at the bottom with a floating Y on top of it. If I write 2 and then X with the floating Y and then 5, then the result of that, I get the same result, 2 to the power 5 being 32. Now, those of you who are using scientific and graphing calculators may not have that button X with the floating Y. And if you're in that situation, then the button that you want to use to do exponents is this one right here, this upper arrow symbol. This symbol right here, this upper arrow, is what I would use to do exponents in this situation. I would type in 2 and then upper arrow and then 5 and then enter. And that would give you the same result, 32, in a Texas Instrument calculator. Now, these two different calculators show us the two main symbols used to represent exponents. The first main symbol that's used to represent exponents is to write your two numbers so that one of them is small and it's positioned on the upper right corner of the other number. So for example, if I wanted to write down 2 to the power 5, I would write down 2, nice big 2 here, and then I would write down a tiny 5 to the upper right of the 2, 2 to the power 5. The alternative way to write exponents, which is more similar to what's on your 83 calculator, if you have one, is to use the little upper arrow. So the other symbol that's used sometimes for exponents is this up arrow. And so you might also see 2 up arrow 5. And this is really common if, for example, you're just using a regular basic keyboard to try and type your math. Now, be aware of the order and the position of these numbers. Just like with division and just like with subtraction, the order of these numbers matters and it will change the result. So the big number here, 2, is what's called the base of what we've written down here. And the small number is what we call the exponent. The exponent would be the small number here. This is the exponent, 5 in this case, and 2 would be the base. So 2 to the power 5, 2 for the base and 5 for the exponent, tells you multiply 5 copies of 2. But if I reverse those values and I put a 5 at the base and I put a 2 in the exponent, if the exponent here is 2 and the base is 5, then this tells me I want you to take 2 copies of 5 and multiply them together. 5 times 5. And the result of that is going to be 25 units, which is really different from the 32 that we found when the numbers were in the other order. Let's do a few more examples of exponents written symbolically. If I have 3 as my large number and 5 as the small number in the corner, here the exponent would be the number in the corner, 5, and the base would be the large number, 3. So this number would be asking me to calculate, take 5 copies of 3, take 5 copies of the base, and multiply them together. So I could calculate that by doing 3 times 3 times 3 times 3 times 3, result 243 units. Or I could use the exponent button on my calculator, 3 exponent button 5, and I would also get 243 from that. If someone said 4 to the power 1, a large 4 and a small 1 in the corner. Here I have an exponent of 1, and here I have a base of 4. And so this is asking me to take 1 copy of 4 and multiply it all together. But of course, if I have 1 copy of 4, there's no real multiplication that I have to do. So this would just be 4 for the result. Now we've seen a couple of words come up for exponents so far. For example, if you see to the power, if you see something like 4 to the power 1, this is asking you to calculate a base of 4 and an exponent of 1. There are also some special words for some special exponents. For example, if someone says square, this means apply an exponent of specifically 2. In other words, multiply 2 copies of the number together. You'll also sometimes hear the word cube. And the word cube is saying apply an exponent of specifically 3. Raise your number to the power 3. In other words, multiply 3 copies of your number together. So for example, if someone says to me, square 4, apply an exponent of 2 to the base of 4. Raise 4 to the power 2. This is saying take 2 copies of 4, multiply them together, and the result of that is 16. If someone says to me cube 7, they're saying to me take 7 and apply an exponent of 3. Take 3 copies of 7 and multiply them together. So this is something that I could do in the calculator, 7 times 7 times 7, or I could use the built-in 7 power 3, 7 up arrow 3, and that gives me a result of 343. Or I could say raise 2 to the power 5. I'll do raise 2 to the power 4 since we've already done the other one. Someone says raise 2 to the power 4, so that's 2 to the power 4. That's 4 copies of 2 multiplied together. So that is 2 times 2 times 2 times 2. That's 16 as well. Now, to give you an example of exponents in the real world, suppose that I'm laying down some floor tiles. And the floor is 6 tiles wide by 6 tiles long. So the question is, if these are the dimensions of the floor, how many tiles would I need to cover the floor in total? So my floor looks like this. I have a tile here, and 1, 2, 3, 4, 5, 6. This is the number of tiles I have in width for my floor. And then I have the same number of tiles in height. 1, 2, 3, 4, 5, and then 6. Go down to make it fit. So the question is, if these are the dimensions of the floor, how many tiles would it take to cover the whole floor? Well, it would take 6 tiles to cover this row. It would take another 6 tiles to cover this row. It would take another 6 tiles to cover this row, another 6 for this row, another 6 for this row, and another 6 for this row. In total, it would require 6 copies of 6 tiles, 6 groups of 6 tiles, 6 times 6 to get the total number of tiles needed for this floor. So in other words, 6 squared tiles. If I square 6, 6 to the power 2, the result of that is 36. And this would be the number of tiles needed to cover this floor. 6 tiles wide by 6 tiles long, 6 squared tiles. For another example, so if you've ever had that special kind of really buttery bread called a croissant, to make a croissant, you put a ton of butter on your bread dough, and then you just fold it and roll it out, and you fold it and roll it out. Editing Sam, please play a video clip to show the audience what I'm talking about. Now, every time I fold the dough, let us suppose that the number of layers of dough is doubled. So if I fold the dough 5 times, how many layers will I have in the end? So if I start with 1 layer of dough, and then I fold it 1 time, then the number of layers is doubled. So the number of layers gets multiplied by 2. This is 1 fold. If I fold it again, then the number of layers gets doubled again. So now I'm up to 2 folds. If I fold it again, then the number of layers gets doubled again. Now I'm up to 3 folds. Then I double it again if I make 4 folds. Then I double it again if I make 5 folds. So what I have written down here from folding the dough 5 times is 1 times 5 copies of 2. Now remember that multiplying by 1 doesn't actually make a difference. If you multiply a number by 1, you get exactly the same number back that you started with. So the only thing here that really matters is the 5 copies of 2 in the back. So this is going to be the same thing as 2 to the power 5. Take 5 copies of 2 and multiply them together. That's what happens if you fold this dough and double the layers 5 times. So this has become a familiar example to us. That is going to give us 32 layers of dough in this bread, 32 layers of delicious buttery goodness for our croissant.